Hello and welcome back to Geek Mania. This is our fourth tutorial on getting started with Python. I'm your host Hamza Mania. Yesterday we spoke about libraries and how to download these libraries using the pip installer. Today we'll talk about functions and I will also use a function from a library. So as you can see on my screen, I imported the factorial function from the math library in Python. Not only that, I also wrote my own functions for factorial, iterative factorial and recursive, factorial recursive. So when you start reading a Python script, you always start from the main block. In the main block, as you can see, I have invoked three functions. First, the factorial from the math library, then the recursive factorial, then the iterative factorial. And I'm passing an argument to each of these functions, factorial of. So in all three cases, I'm computing the factorial of 4. So first of all, we'll invoke this script and we will see what the output is. As you can see, for all three, the output is the same. So let's look into these functions. First of all, I use the function factorial, which is predefined in this math library. Actually, it is a good idea to reuse what is already implemented rather than inventing your own wheel in most cases. However, just for the sake of illustration and going into more details about how to implement your own functions, I picked up this example of factorial. So here, as you can see, first of all, I'm invoking the factorial recursive. So first of all, I would discuss what is the difference between iterative and recursive. Recursive is a call type in which the function that is called by the caller is called inside the function body itself. In case of factorial, as you know, if the factorial of the number to be computed is greater than equals to 1, then you have to call factorial n minus 1 multiply by the number itself. So we will do this recursively till the number is 0. The factorial of 0 is always 1. So in this case, first of all, let's look into how this will be called. First of all, let's construct a call stack. First of all, I'm just trying to dry run this line of code and then we will go into what each of these calls will return and we will get to the result in a moment. So as you can see here that a single call factorial recursive of 4 is internally calling the factorial recursive for n times. Here n is 4 plus 1. 1, 2, 3, 4, 5. So what will each of these calls return? So here the return will be 1. Again the return will be 1. The return for this factorial will be 1 into 2, which will be 2. Return of this call will be 2 into 3, which will be 6. And finally, this will return 6 into 4, which will be 24. So this is how the recursive call works. As you can see, like I have also placed comments just for the sake of elaboration all across the code. So it is always a good idea to well comment your code. Another thing that I want to discuss here in this code is the exception handling block. Exceptions are something which is unexpected. For example, for a factorial function, it is not expected that a negative number will be passed here to this function. For example, if the number is greater than equals to 1, then this block will be called. If it is equals to 0, this will be called. And if it is less than 0, then this block will be called. If this block is not there, this will lead into a fatal error. Fatal error is a error which causes your program to crash. So since here we are calling the function recursively inside the function itself, if the number is negative and I subtract -1 from negative, this will go down to negative infinity. Therefore, there will be infinite recursions of this function, which will lead to stack overflow and eventually a fatal error, which will crash your program and perhaps also malfunction your system. This is something that we want to avoid. We will go into more details of exception handling and like how to uh, use a more generic versus more specified error codes. So here again, I tried to elaborate a little bit more about this. Normally, negative values indicate an error. Therefore, maybe one generic error code or dedicated error codes for each scenario might be used here. So, yeah, once we do a tutorial on exceptions, we will go into exception and error codes. Another thing that I want to focus on here is that here the this parameter to the function. So when basically you define a function and in the brackets you declare a variable, this is normally termed as a parameter of the function. Whereas when you pass some variable to this function, this is termed as the argument to this function versus the parameter to the function. So this is the difference between parameter and argument. So as you can see, this parameter is expected over here. However, the user may forget. For example, I will remove it from here and try to invoke the same Python script. And you will see that here it says missing one required positional argument. So for the sake of handling this error, we normally don't want the program to crash in this case. So we specify default values of the arguments. So for example, we can say factorial equals to 4. And even if I remove this argument from here, then the script will still run. So it is always a good idea to specify default values for these parameters. I will do the same with my iterative function. Now we learned about what is recursive. Now let's talk about iterative. As compared to recursively calling the function from its own body, the iterative call runs a loop. For example, after the same sanity test that we made over here, that the factorial is greater than equals to 0, Here, although this will not cause a fatal error, yeah, we are just doing this check because we believe in uniformity and quality of code. Therefore, this is quite necessary. So here we run across the factorial of which is the argument to this function, and we iteratively decrement this variable and multiply it to the result, and eventually we return this result. Another thing that I wanted to focus on during this tutorial is the keyword return. So when you specify this keyword return from a function, basically this returns a variable from this function to the caller function. So here in this case it is returning an integer result. The result is the factorial of the argumented number, and I am printing this number here. Therefore you can see this output. I hope you liked today's tutorial and you are getting further on your journey. Please like and subscribe and share. Thanks for your time. Thank you.